This is another example of solving a system of linear equations using the elimination by addition method. But this time, this one doesn't eliminate like that. Meaning, if you were to add these together, the 2x and the 3x would add up to 5x. The 3y and the negative 4 would add up to negative y. And right there, neither the x nor the y got eliminated. So, it's not working the way it's supposed to. You're going to have to make it happen. Alright, so I erased that. Now, you have to decide, do you want to cancel out your x's or do you want to cancel out your y's? It really doesn't matter which, but one of them needs to be a positive and the other one needs to be a negative so that when you add them, they cancel out. And since my y's are already opposite signs, I'm going to cancel out my y's. The problem is one of them's a 3 and the other one's a 4. They need to both be the same number. Now these are equations, so when you're in equation land, you have to abide by equation laws, and the biggest law is what you do to one side of an equation, you have to do to the other. So, somehow I have to change my 3 and my 4 into the same number. So you're going to use the same thought process that you would for finding a common denominator, even though these aren't fractions. I'm looking at the 3 and the 4, and I'm like, what number does both 3 and 4 go into? Now, there's a lot of them. They both go into 12, they both go into 24, they both go into 36. Really doesn't matter which one you pick, but I'm going to go with the smallest, and that would be 12. So what I'm going to do is I'm going to take the top equation, and I'm going to multiply everybody by 4. What you do to one side, you do to the other. So this 4 is going to get distributed to all three pieces of the equation. 4 times 2x is 8x. 4 times 3y is plus 12y. And 4 times 14 is 64. But then I'm going to take the second equation and I'm going to multiply that by a 3. And what you do to one side, you got to do to the other. So you literally distribute 3 to both sides. And 3 times 3x is 9x. 3 times the minus 4y is minus 12y. And 3 times a negative 13 is a negative 39. So that right here, when you go to add the two equations together, boom, right there, the plus 12y and the minus 12y cancel out. There you go. But you still have to combine your other variables or your other pieces of the equation. So when I add my 8x and my 9x, that adds up to 17x. The y's canceled. Here's my equal sign. And then the 64 minus the 39. Whoops, I just made a mistake. Sorry about that. I'm not very good at math. Okay, 4 times 14 is 56. Holy moly. I was thinking 4 times 16. My bad. All right, so now when I take the 56 minus the 39, I get 17. That's much better because I was like, wait a minute. That ain't the right answer. And then, of course, the last step is divide both sides by 17. Your 17s cancel, and x is equal to a 1. And then you're just going to take that x is equal to 1, and you're going to take it back to one of the two equations that are written in black. Either one, plug it in for x, and solve for y. I personally would rather deal with the positive y than a negative y, so I'm going to take it and put it right here. So this is going to become 2 times x was 1 plus 3y equals 14. And then 2 times 1 is 2. And then I'm going to start solving for y. I'll subtract 2 on the left to cancel that out, but I got to subtract 2 on the right. And I'm going to be left with 3y is equal to 12, kind of running out of room here. So then I'm going to take my 3y is equal to 12, and I'm going to divide both sides by 3 so that the 3's cancel. And y is equal to 12 divided by 3 is 4. Now Alex just has you plug in 1 for x and 4 for y. But really what you're finding is the point where these two lines intersect. It's actually an ordered pair. It's the point 1, 4. Because it is a linear system. Of course, you can apply this to word problems too. And 1 and 4 could mean something else. But, you know, just keep that in mind. It's really the point where these two lines intersect if you were to graph them. Now, the only way you can make this even harder is if both of your x's are positive and both of your y's are positive. So if this had been a, let's say, let me pick another color here. How about pink? If this had been a plus 4y right here, then the only difference is I would have had to have multiplied by -3 to make it a -12. Or I suppose you could multiply the top one by -4 to make it a -12. One of them would just have to be negative. So just look out for that also. Have fun.